Hi, if you're here, you're trying to turn an equirectangular map into a globe, be it for digital use or print use. Here's an example of print use. Um, I printed it. So this comes from an image here on, I downloaded this from NASA. We're gonna use Blender just a couple steps, by which I mean probably like 10 steps, to turn it into this. This is much better for, you can see the distortion across the top here and the bottom here is insane compared to, doesn't that look a lot more like Antarctica? So, um, so yeah, the distortion is a lot more evenly distributed here. It's a lot better for drawing on if you're drawing your own map. So I've downloaded this from NASA, but this also works if you have some map generator like Asgar's Fantasy Map Generator or Procgenesis that outputs a or outputs an equirectangular map. So equirectangular is your keyword here. Look for an equirectangular map and get into Blender. If you're using either of these, I'm gonna have some tips at the very end of the video, quite brief, to give you some warnings. So I'm just gonna start us off. We're gonna add a icosphere. Subdivisions will make it look fine. You should note already that this UV map is basically what we want, but we'll make some changes to that last. So, but it's pretty much what we want. We want to also add a camera, and we don't want a weird viewing angle. Let's zero that out and then just let's rotate it up so that it's pointed to the side, kind of representing the angle that we would look at for an equirectangular map. So set X to 90. That's great. We're gonna quick select it and say set as active camera, and now that's gonna be the default camera used for the next step. So we're going to select this. We're going to go into shading and click new with that object selected. And the shader for this, we need two textures, image textures. And the first one is going to be, let's go here. The first one is gonna be this equirectangular map, and I'm gonna change it. You don't have to do this, but I'm, for demonstration, gonna say this is closest and clip, but both of those settings are settings you can leave alone. I'm gonna add a an input texture coordinate. And this is important, connect the equirectangular map to the window coordinates, and on this side make the shader be an emission shader, and connect that out to surface. So if you've done everything correct at this point, you should be able to zoom in on the globe, and it should look like this. No matter where you look at the globe, it should stretch out this image depending on how big this viewport is, right? So if you have that result, you've done everything right. And on this one, hit new, and I'm gonna say the dimensions are 8,000 by 3,779, and we'll talk about the math later if you want to have a different size image. Okay. With this selected, I'm going to go to we need to use cycles. We're going to use the ability of cycles to do baking. So set the samples under render, not under viewport. Set samples to max samples to 1. And that's because we don't really need to be sampling this image too much. It's already the exact image we want. We don't just check what color the pixel is and move on. It's going to be faster that way. So max samples is 1, and we come down to baking, and here it matters whether you're going to print or do digital. I have already, so this example I did was digital, and for that I set adjacent faces is or this margin I set to adjacent faces, 16 pixels. But now I'm going to set it to 1 pixel for print. So that just means if we look back at this image and we zoom in, we can kind of see this seam here. This is the actual edge of the face as it is drawn in Blender, and it adds some extra pixel data there in case there's like off by 1 pixels, so that it still renders the correct pixel, doesn't immediately render a black seam digitally. But if you get rid of this margin, it'll be more accurate when you cut it out if you're printing it. So, or you could leave the margin in, print it, and just make sure to cut it right. If you have some other way to make sure that you're cutting it right, that'd be a good. Anyway, that's up to you. So I'm going to set it to 1 just for demonstration purposes. Make sure you have the object selected, this brand new blank image that you've generated, and click bake. Bake on emit. Click bake. Okay, so from that, we're going to see that it didn't actually fully do it right, but I'll show you. So here's the two things we did wrong. One is it's not projected onto the full globe. That's a problem with the camera settings. So we got to select the camera, go into camera settings, and change the type from perspective to panoramic, and do equirectangular and leave the rest of these settings alone. Now this little map will be stretched across the full globe. The other thing you'll notice is wrong is this this map is backwards. So and the problem is that this camera is looking from the inside of the globe out. So from the camera's perspective, that map's forwards, but we're looking at the outside of the globe. So we actually want it to flip the camera. And so we can select this camera and set the X scale to -1. It's going to flip it left to right. And now we won't have that problem anymore. So one more time, select the globe, select the texture, make sure that your nodes are still pointing at the equirectangular texture, but select the texture you're baking into and click bake. And that's done. We should find that this is all correct. So at this point, you can save this you can save this texture. You should go ahead, if you're done now, hover over here, hit Alt S, and go ahead and save the texture, because this will not automatically be saved in your Blender file. You have to save it as a file. So right now you can see we have a usable globe. You could print out that image. You could do yeah, you could just use this as a ball in a video or in a video game, whatever you need. Virtual tabletop game, whatever. I'm going to show you a change we can make, which is that in UV editing, we zoom out here. We switch to UV editing with this sphere selected, and so we're in edit mode. We hit A to select everything, and we see these faces come up here. Before we actually selected a texture, and when the texture was, before we selected a texture, the texture was 1:1 ratio, but I actually have it, I told you to enter in 3779 for the height, and that's because we want to actually scale this. So here's the math there, which is if we figure out what these size ratios should be, the width here is 5.5 of these triangles, so 5.5 triangles wide, and as far as lengths along the triangle, it's 3√3/2 triangles tall. So in Desmos, whatever your width is, multiply it by 3√3/2 and divide by 5.5, and here we're getting 3779, but if you wanted a higher or lower pixel ratio, you could do you could figure out what the ratio should be by doing this math. but that does mean we need to adapt our triangles in Blender. So if we're multiplying by a on the height, we need to divide by a on how tall they're represented in Blender. So I've just copied that scale value 1 over a. I'm going to set the scale. I don't want to scale from the middle. I want to scale from the bottom. So I select the 2D cursor. Now we're scaling from the bottom. And so I'm going to hit S and Y. So we're now locked on the Y-axis. I'm going to paste and hit enter. So now that's correct, but we need to redo the map again. So again, make sure that you've got the equirectangular thing. Make sure that it does this whole thing when you're panning around. Select the object, select this texture, and click bake one more time. Okay, so that's all done. We can connect it up. This is our ball the same way it was before, but the ratios of the texture are going to be slightly better. Okay, so again, at this point, if that's all you need, go forth and conquer, but let me show you another trick if you want to draw over your map. So the following tips are pretty much for people making their own map using this or this. So here's what you need to know. Neither of them is actually equirectangular because equirectangular mappings have stretching across the top and bottom. I can show you the tectonic plates that this generates. These clearly are not accounting for stretching because basically if they were actually accounting for stretching, one of these individual plates would take up the whole bottom border and one of these would take up the whole top border. So this was generated on the plane instead of generated on a globe, so it's not going to work perfect. So if you take either of these two maps and plug it into Blender, you're going to see some major spiking happen at the globe, at the poles, as it pulls all those points together. So you might want to draw over it. So, or if you want to draw over it for any other reason. So this is only relevant for the baking. I'm going to put it off to the side. We no longer need it. So this one I'm gonna delete and hit new, and I want to do the same size image, but for the color, set the alpha to 0. And what we're gonna do is mix these two. So shift add color, mix color, use the factor here and set this color to B, set this color to A. And hopefully this still works. But the difference here is now we've got this blank image that is being overlaid on your original map. So take this blank image, make sure you have this one selected when you switch into the texture paint tab. And in texture paint, you can switch to, instead of viewport shading, which is only showing you this empty image on the globe, now you can, instead of doing solid mode, you can do material preview mode or render preview. Now it's showing you the two overlaid on each other, and if we draw on it, it should appear here. So and now you know, go forth and learn all of the Blender drawing tools, but that's your job, not mine. So I can draw a circle here, and maybe that's the way I wanted it to look on the map, but it's going to come out correctly warped on the image. And so that's the advantage of doing this. And at the poles, you could come and you know, if the shape of something is wrong at the poles, you could come and correct it in here and do anything you want with a map overlay. So yeah, be careful drawing at the edges. Things get weird at the edges. So that's my warnings for you. Some other warnings are, I think just one other, or two. One for each of these. One for Proc Genesis, which is you can select different map sizes, and I recommend doing the extremely large one if if you're trying to map it into here because you want a high quality image. Once you stretch it out onto a globe, you want all the texture detail you can get. So And the other one is that Asgar's procgenesis, you'll notice it loops around from side to side. East-west edges have the same things going on. If I switch back to satellite, you can see that land here connects to land here, etc. Asgar's does not have that advantage. If I click this a couple times, we're eventually going to get a map where the continent does touch the east or west side, and long story short, it does not line up properly. Boy, it doesn't usually take this long. Usually it takes a couple clicks. Okay. And that's a bad example because it kind of lines up. But you can see here that, in fact, I don't need to have you guess. I can just show you the globe. Somewhere there's a seam, right? Do you see this seam? This is like, yeah, it kind of thought it was doing something, but it didn't. And you can see this warping that I was talking about at the points. It just, neither of these two get the warping right at the poles. And this one also doesn't get the seam, but this one at least gets the seam. So just when you're hitting new map, make sure you choose a map that make sure you choose a map that does not touch the edge of the world. So if we go to globe here, this is fine because they had a big ocean at the edges. So play with whatever settings you want. I think that's everything I want to show you. I wish you luck. Thanks for checking out this video, and let me know in the comments if you do anything cool with this. I would love to see it. So bye.